Hey guys, what's up? So this is gonna be kind of a bit of a different tutorial, I guess you could call it, but it's really just a kind of like a review session for stuff that I think you guys might find pretty useful for the test tomorrow. Um, so I've actually gone over the test and I've wrote it as if I was a student, and I think it's a really fair test. I think in terms of difficulty, uh, definitely easier than some of the assignment problems you've done. So I really don't think you guys are going to have too much trouble. And of course, there's going to be Piazza if you need any clarification for any of the questions. So the plan today is to go over some of the concepts that I think you guys might find really useful. And they're all concepts that you've learned and that you've dealt with in the assignments. But I just wanted to kind of put a little bit of emphasis on them in this stream, and also show you guys a bit of how they work on Python. So let's turn this on. Okay. So you can see here, I have a small Jupyter Hub notebook, or just a Jupyter notebook open, and it's got some cells that I want to cover. So there are a few concepts that I need to clarify. The first, I just really wanted to clarify between you guys the difference between import and from import, because some people have been having trouble with that, and you need to have it straightened out, because if there are errors in the compilation of your code in the test, there won't be any sympathy for that stuff. So if your code does not compile, I really think Professor Moore just might give you a 0 if it just does not compile. And so first of all, you need to make sure that it compiles before you submit it. And second of all, you need to know what might cause it to not compile. So let's take a look at this very simple function. Here we import math, just like you guys are used to. We have a function that takes in a variable I and returns its square root, okay? And outside of the function definition, we print the value of that function with the input 9. So what happens if we try and run this? Okay, one sec. Give me a quick sec. I'm actually not sure why that's happening. Let's try. Ooh, okay, I think I understand what's happening. Let's move this one up. Sorry, okay, yes, I understand now. So, here we have from math import square root, okay? And we have a function that takes in the thing, whatever. We try running it, and we're gonna get a name error because name math is not defined. And that's because you're trying to reference the square root function with the math prefix. If you're using from math import something, you should not have the prefix. I've written a Piazza post about this that you can find if you want. But there should not be a prefix if you're using this form of the import. Yeah, Michael, I know. That's why I really want to correct it for this test, so that no one makes any of these mistakes. And then if you go over here, if you import math, you need to use this prefix, and you'll see that if you run it, it works. And well, we already imported math, but if you have this on a like on a blank notebook and you've never run it before, and you just try submitting this, you will have the same name error. It'll say square root is not defined, because with the import math, you need math.square root. So end of the day, this is how it should look, right? If you're using this, use this. If you're using just import, then please use the prefix. Okay? Now that that's out of the way, I wanted to go over something else. And that's order of Boolean evaluation. So when you guys do if conditions, right? Let's add another cell below here. You have things like if A, like let's say A is a condition, right? If A or B or C. So you can say like, you know, these are all conditions. These are all Booleans. They can be true or false, right? When you have multiple of these, the order in which you put them matters. Because when Python evaluates a Boolean expression, if there's an or here, then only one of these needs to be true in order for whatever is inside the if statement to actually run, right? Because it's an or statement. So if this is true, if condition A is true, it won't even evaluate B, because it knows it could just skip it. It would be a waste of time for Python to try and evaluate B, because A is already true, so it knows it can run this code, right? However, if A is false, then Python is forced to evaluate B to see if B is true or false, because if B is true, then we can run, and if B is false, then that means both of these are false, and we can't run what's in here. So I will go a bit further with this explanation, and this is pretty relevant to what you guys are going to be doing tomorrow. It might not seem so, but you will notice something. You will notice a scenario where this stuff matters, and I will elaborate. So here we have a print statement that prints the value of 1 over 0. Yeah, the stream will be posted tonight. All of these streams are always saved onto the YouTube channel, so you can always go back and look at them. By the way, all we've gone over so far is the difference between from like math import and import when you're importing modules. Anyways, so I'm sure you guys know that 1 over 0, anything over 0, would give you an error, and the same goes for Python. If you try and run a calculation which involves 1 over 0, you get this 0 division error. Okay, so you might be able to see where we're going with this. We have something that gives an error, and I just talked to you about the importance of the order of Boolean evaluation. So here we have a simple function definition with the same form that I discussed, if A or B, right? We have if 5 is equal to 5, or 1 divided by 0 is equal to 2, then print success. And we call the function right here. So what do you guys think is going to happen? Is it going to print success, or is it not going to print success? Or is it going to give us an error? Because we're dividing by 0 here, right? Zero division error. Is it going to give us a zero division error? Right. So yeah, exactly. Based on what I just said up here, since 5 is equivalent to 5, this condition is true. And since the rest is just on the other side of the or, right? If we run this, you'll see that it prints success. It doesn't give a zero division error, even though we're dividing by 0 here, because this condition never gets evaluated. That's very important. It never gets evaluated. Compared to if we flip these around in terms of order, right? This condition or this condition, even though this condition is true, if we try running this test, we'll get a zero division error because this is the first thing it evaluates. Instantly, boom, Python crashes. It has an error because 1 divided by 0, zero division error, right? So the reason why I'm bringing this up to you guys is because this is going to matter for you on the test tomorrow. You're going to be faced with a problem. I guess I shouldn't go too much in detail, but it will involve making sure that you don't hit an error when you're checking something by using an if condition of this form. All right, and this is relevant to what I'm about to do here. So we're going to be doing some work with 2D grids, right? A 2D grid can be expressed in Python as a 2D list. So I'm going to quickly switch over the view to Microsoft Paint. So hopefully you guys can see this right now. So here I set up a very simple 2D grid. And basically, obviously, these are the rows, right? And these are the columns. So you have row 0 up here, row 1, row 2, and column 0, column 1, column 2, column 3, okay? And here is a problem that we're going to try and code up. If I give you a cell on this grid, and I ask you, what's the sum of all of the cells that surround that cell? That could be a function that you have to write, right? So if I say, what's the sum of all cells that surround the point, let's say 1, 2, right? 1, 2, let's go to 1, 2, we go row 1, column 2, right? So it's this cell right here, 1, 2. So let's say now, let's say that we include the value of the actual given cell in the sum. So it's the sum of all the cells surrounding and the actual cell that we're talking about. So that would be 2, 5, which is 7, 10, 12, plus 9, which is 21, 21 still, plus 0, 22, and plus another 8, which is 30, right? So unless I made a mistake, the sum there should be 30. So our function would take this in as input and return 30. Cool. And here's the thing. What if I asked you instead for the sum? Okay, we can backspace. So what if I asked you instead for the sum of the points 1, 0, right? 1, 2 is over here, but 1, 0 is right here, right? Well, previously, right, the way you computed the sum around this cell is, I'm sure you guys can probably figure out, you would have initialized the sum variable, and you would have checked this cell, this cell, this cell, this cell, this cell, this cell, all of these cells, and added them to the sum function. So you would have checked the one to the left and up, just up, so on. If we're over here on this cell, then if you try to check the cell to the left, or the cell to the left and up, or the cell to the left and down, right? Any of these directions, you will go out of bounds. You will be out of bounds of the grid. Similarly, if I asked you to find the sum around this cell, if you tried to go over here, or over here, or over here, you would go out of bounds, and you would get an error. So you would crash. Your Python code would crash. Not this exact question, but something that involves the same concept, which is why I'm explaining to you right now, right? So the trick is you don't want to go out of bounds. So that brings us back. That brings us back to this code. What we can do is we can check the sum we can check the sum only if it's within the bounds. And we have to make sure that we check the bounds before we do the actual code execution, right? Before we compare, before the code execution. We have to make sure that we check it before the other condition. Because if we try and access a cell that is out of bounds, then we'll get an error. But if we check if it's in bounds here in A, and it's false, then it won't even consider B, aka it won't try and evaluate the cell of that function, right? So that's kind of the main point that I wanted to go here. Let's let's see here. I'm gonna modify this a bit. Okay, for the sake of this question. I'm gonna make all these 7s right here. Cool. And the question, let's fix this accordingly. This would be 7273. Oops, you guys couldn't actually see the paint. Sorry, I keep forgetting about that. So I made a quick change. I changed all of these cells to 7s. And you'll see exactly why I did that. So we can just correct our code over here. 273, 11144. Okay, cool. So let's try and code this function up, just as it is right now. Find the sum of all cells surrounding a given cell. And we're going to do including the given cell. Cool. So how can we do this? Well, first, we can initialize a sum variable. So we can say result sum equals 0. And we can say, let's do the naive solution first, right? We can say for I in range, -1, 0, 1. For j in range, -1, 0, 1. If you guys are a bit confused right now, I'll explain this very soon. It will all make sense. And then we can say if, or actually we could just say result sum plus equals, right? Which is basically result sum equals result sum plus board at A plus I, B plus J. Cool. And you guys might be able to see why this works, right? If we have a grid, I and j are both going to cycle through -1 to 1. So basically, these indices, a plus I and b plus j, are going to cycle from, like this term is going to have 3 different values possible. It's going to be either I minus 1, just I, or I plus 1, right? Because a can be -1, 0, or 1. And b plus j, this term, is also going to be either j minus 1, j, or j plus 1. So that would basically allow us, right? This would be 9 different checks in total, 9 different combinations. So we would be able to check the 9 cells that form, like the 9 cells that surround a given cell, right? And we can return result sum at the end. Cool. So we have this example. Let's format it like this, just so you guys can see properly. Cool. So let's say we wanted to get around here, right? This is row number 1 and column number 1. So this would be 1, 1. So we'll call our test2 function on with mygrid as the board, right? Mygrid is the 2D list that we defined up here. Mygrid, and for A, we'll pass in 1, and for B, we'll pass in 1, because we're trying to find the sum around this cell. And let's print that value. So we'll surround it in a print statement, right? Okay. That was not quite what we wanted. Should be a lot bigger than that. Does anyone know where I screwed up? I'm trying to find it right now. Oops, sorry. There should not be a range here. We're looping through the tuples, not the range. My bad. So here we go. 50. So let's verify that. We have 7, 9, 16, 23, 25, 34, 45, 46, 50. Okay? So the cells that surround it do add up to 50. So we're right there. Here's the issue, right? What if we tried changing this to 0, 1, right? Now we want the sum of the cells that surround 0, 1. Where's 0, 1? 0, 1 is this one right here, right? It's this 2 on the top row. If we try running this, oh boy, what's wrong? Oh, okay, I see what's going on. Let me change this example real quick. The reason it's working, I think, is because it's 0, 1, like it's actually overflowing and it's coming back under here, so it's counting these ones. But I'm not sure. Yeah, I think that is it. So let's try something on this edge. Let's try, this would be row 0 right here. And it's be 0, 1, 2. Let's try it, row 0, column 3. So 0, 3. Okay. So we try with 0, 3, and we get an index error, which is exactly what we expected. The list index goes out of range because if A is 0 and B is 3, then when J is this plus 1 here, right, it's gonna flow past, right? Like this will be B plus J, this will be 4, and you'll be trying to do you're going to be trying to have a 4 in this index slot, and this only goes up to 3, right? It goes from 0 to 3. So you're trying to go somewhere out of bounds. So we can do something here. We can say, if let's say if a plus I, right? If a plus I is in bounds, then we can do this, right? So if a plus I is greater than 0 and a plus I is less than what? A plus I is determining which row, right? A plus I is this index, and this decides which row we're trying to access. So we want to make sure that we're not going past our rows. How many rows here? We have 3, aka the length of this grid. So let's define these variables here. We'll say height equals length of my grid, right? Because length of my grid, this is a 2D list. And this 2D list contains 3 lists, aka 3 rows. And our height is the number of rows. So by doing length of my grid, or sorry, I guess it would be board here, because we're talking about the passed in function, the passed in grid, then we would get 3. So this is the correct way to find the height of the grid that's passed in. We can also do width here, and we can make an assumption. You can make an assumption that that if it's a 2D grid, then obviously all of the rows are of the same length. So in order to find the width, you just need to find the length of one of these inner rows. So we can say the length of board at 0. Because we're basically assuming that this first row is the same size as all the other rows. So that's how we can find the width, right? Now we have the height and the width. We can say only add this to the result sum if a plus I is greater than 0 and a plus I is less than height. And b plus j is greater than 0 and b plus j is less than width. Cool. And so now, if we run this, we get 9. And if you check, well, now we have a bit of confusion. Why is this happening? I don't think it should be 9, no? 0, 1, 2, 3. It should be like 19. Oh, okay. I have a question. Difference between in and range. Yeah, range will basically just go like, it will go stepwise, like step by step up to the value, whereas in will evaluate everything in like a sequence or like a tuple or a list or a string, right? These numbers could be anything here, and I will take on the value of each of these values one by one, whereas range would kind of go stepwise. So range, like I shouldn't have even been using range here because it just wouldn't have made sense. I want to cycle between these values. Let's figure this out. So let's do some debugging. We'll say print a plus I, b plus j. So these are the cells that, like these ones that we're printing are the ones that pass this if condition. So 1 and 2, 1, 2 is passing. 1, 2, which is right here. 1, 3 is passing. But nothing else? So why isn't 0, 2 passing? Oh, greater or equal to 0. Of course. There we go. Easy fix. So now we get 19, which is the correct answer. 7 plus 3 is 10, plus 9 is 19. And this 0 obviously contributes nothing. So we were trying to find the sum around this point right here. Would range not have worked? Well, let's test it out. So let's insert a cell below. And we can say list. Well, if we just make a range object of 1 to 7, right, we get this. It just outputs the range object. So you can turn a range object into a list to actually see what it's going through. You can see that it goes from 1 up till 6, okay? If we go -1 to 1, you get -1, 0. If you have what we had, it wouldn't work because the way the range arguments work is the first argument is where you start. The second argument is where you end exclusively, so it doesn't actually count this index. And the third argument, which is optional, is the step. So we're saying we're going to increment by 1 each time. But so we start at -1, but we stop exclusively at 0, which means that we stop right here. We stop at -1 because we can't go more. We can't go higher by 1 because we'd hit 0. And we're not allowed to hit the second argument, right? It's exclusive. If you change this to like 3, you'd have -1, 0, 1, 2, all the way up to, but not including 3. Cool? So that's how that works. So yeah, that's why we used in instead of using range here, because we just want to cycle through here. We could have done, you don't need the step thing, but we could have done this, right? This would have been the same thing. Range from -1 up to, but not including 2. But I just wanted to specify the values. Anyways, let's go back up here. So now we have something that works, right? This is very important. You should know how to do this because similar concepts, like this is a very popular concept in programming, which is knowing how to treat a 2D list as a grid. There will be so many cases where you have to treat a 2D list as a grid, interpret it as a grid, check surrounding cells, check to make sure that you're not going out of bounds when you're checking surrounding cells, right? That's all very important. What else? Cool. Let's say, let's make a small change, or we can say update. Only add the cell's value to the sum if the cell's value is not 7, okay? So let's try and make this change. We want to do the exact same thing, but we only want to add that cell's value to the sum if that cell's value is not 7. Cool. So we can do that pretty easily. We can just say we can add another condition. Right? We can add another condition and board at a plus I, b plus j is not equal to, this is how we do not equal to in Python, is not equal to 7. Cool? And that should work, right? You'd think, because it just won't run, it just won't add it to the sum if this is not true. So let's do this cell right here, 1, 1 again. We run it, we get 29. So it shouldn't be counting these 3 7s around here. Which this makes sense because earlier when we were counting them, our result was 50, and now we're not counting 3 7s, aka we're not counting 21 in total. So 50 minus 21 is 29. And if you count these individually, you'll see that 2 plus 2 is 4, 4 plus 9 is 13, 24, 25, 29. Cool. So the math checks out. That was a very simple thing to do. Here is something important. Let me think about this. So, okay, in this case, if we did something like this, right, and we added here, oops, forgot to remove this and. This is fine. The reason this works if we change the order is because since all of these are ands, right, you're actually fine to have them in any order you'd like, because Python still needs to evaluate them, needs to evaluate all these conditions because they're all ANDed together. So it's not like an OR where it can stop as soon as it finds one. One more thing. Okay, actually here. Sorry. Take that back. Let's try changing our grid. Right? So we have this grid. Let's try going here, right? This cell right here, this first 7. So that's on row 1, column 0. So we would have row 1, 0. Cool. If we ran this, we'll get 16. Okay, let's not do that either. Sorry. These are not really good examples for what I'm trying to do. This is not the correct sum, I don't believe, but I'll get to that in a bit. Let's try this cell right here. This is row 1, column 3. So we'll change this to a 3. We get an index error. This is also expected. We get an index error because we're over here and we're trying to calculate board at a position that doesn't exist. We're trying to calculate the value at a position that doesn't even exist. So the second we try to do a plus I, b plus j, whatever, and it goes past the limits, then we crash. So if you move this condition over here, at the end of it, it would work fine. And I hope you guys can see why it would work fine. The reason why it would work fine is because if the current cell that we're trying to look at is actually out of bounds, then these conditions won't pass, right? Let's say, for example, we're trying to look at b plus j, but we're already here and j is 1, right? We're trying to add 1 to 3 in this case. So we would try to go board at something at 4 is our second index. This only goes from 0 to 3, so 4 does not exist. You would be trying to access something that doesn't exist, which means that this would fail. b plus j less than width would fail. And as soon as something fails here, this would come back false. Python, just like how if something is true with a bunch of ORed conditions, it will just skip the rest, right? In the same way, if a bunch of things are ANDed together and it hits something that's false, well, it knows the whole thing is going to be false, right? Because if things are ANDed together, right, like you AND them together, and one of them is false, well, the whole thing is false because they all need to be true in order for the condition to be true, right? Which is why putting the actual calculation or the part where we access the board at the end helps us avoid an error, because it means that if we're out of bounds, these conditions will catch it first and it will allow Python to skip the actual calculation, which means it won't run the calculation, which means we won't get an error, which is exactly why we want. So I'll add here, or actually I'll add right above it. Make sure to check if cell is in bounds before trying to access that cell to avoid error. Cool? That's the whole reasoning behind this. And that is actually one of the main reasons, that's probably the main reason that I wanted to have this tutorial, this test review session, whatever you want to call it today, is to teach you guys about this concept. And this concept's not just for this test, like I said, it's a very prevalent concept in programming. You'll be doing it all the time, treating 2D lists as grids and making sure that you don't go out of bounds. Cool. So that's very important. That's very important. Now, if we go back to something earlier, which is 1, 0, I said, I thought this wouldn't work, but it did work. And I'll explain to you why. It didn't actually work. Let me show you, right? 1, 0 is talking about this cell. It's talking about 7. If you add up all the cells that surround 7 that are not equal to 7, you get 11. Wait, hold on. 16, is this right? Oh, okay, my bad. I forgot to put it back. Still 16. Okay. Mm. One, 0. That are not equal to 7. So you have 2, 2, 1, that's 5, plus 11 is 16. Oh, right, okay. This works because of our checks. Or wait, not equal to 7. Oh, okay, I see. All right, in this case, it's fine. In this case, it's fine because of the way the ands work out. It turns out you actually get the same answer. But the point still stands. The point stands is that in order to avoid the possibility of an error, which very well could happen if we went 1, 3 here, and that's going to happen, right? Many of your auto-graded test cases, like those test cases can contain any numbers we want, right? We're trying to raise errors when we do test cases, so you have to make sure that your code is error proof, basically, right? Of course, like within reason, right? We're not going to cheat you out of grades, but so you have to make sure that you check this condition at the end for the reasons I explained to avoid an error. Okay, now we get the right answer. So that covers that. Small modification. First, we said here, including the cell. Let's try now. Let's try excluding the cell. So we'll do the same thing. We're basically going to copy it. We're going to say test2 excluding. I guess we should make it all caps. Excluding. Cool. So this is the same thing. But over here, we're going to say excluding the cell. What this means is that if we called this function on, for example, 1, 3 right here, previously it was giving us 20, right? 10, or sorry, you don't count the 7. It would be 8 plus 9, which is 17, plus 3 is 20, right? Oh, shoot. Okay, this is 0, so it wouldn't change anything. Let's try this too. So this would be 1, 1, right? If we don't like we want to exclude this cell. So we don't want to count the 2 that we're actually given. So the way we can change that, it's a simple change, right? You're only looking at the cell you're talking about if I and j are both 0, right? If I and j are 0, then a plus I is just a, b plus j is just b, which means you're really accessing the board at AB. And AB is the cell that you're given. So if you don't want to count the cell that you're given, then you don't want to add the cell's value to the sum if I and j are both 0. Because if I and j are both 0, then you're basically talking about board at A, B, which would be the given cell in this case, right? You don't want to count it. So simple thing again, you'd say as long as I let's see. So we want to say if I, okay, I is equal to 0 and j is equal to 0, we want to make sure that's not true. So we can say not. Not basically flips like if this turns out to be true, then not like the not true is false. You know, true is true down here. Not true is false, and obviously not false is true. The same thing as saying not is you could just put an exclamation point here. It's the same thing. So we're saying the same conditions as before, but additionally, as long as I and j are not both equal to 0. As long as they're both not equal to 0, then add that cell to the sum. Cool. So okay, sorry. I guess you can't do that. Just use not then. Is this working the way I intended to? Okay, so essentially we can think of the AND function as a nested if statement, kind of. Yes, you can. And that's actually pretty relevant to your test as well. There's a question that is very much about, well, actually, that question doesn't really use ANDs, but there's a question that tests your basic knowledge of if conditions, like using conditionals. Like it sounds really basic, and that's because it is. You just need to know how your if, else it, like your if, your else's, your elifs. Just make sure you understand how those all work. It's a very simple question. Anyways, let's try and figure this out. I don't know why this is not working. My grid at 1 and 1 is right here. 2, 11, 15, 16, 27. Oh, that's right. Sorry, guys. This exclusion example still contains a plus I equals b plus j is not equal to 7. Where? Oh no. We still want that. So let me like I was still counting that, but we can add that. Cool. So sorry guys, it actually does work. If you add it up, right, we have 2 here. We obviously don't count any of these 7s because our code has this and the cell is not equal to 7, right? So we have 2, 2, this 9 is 11, this 4 is 15, 16, 27. And that's without counting this 2 that we're given, right? So if we remove that condition, we get 29, because now our function is counting that given 2, right? It's counting it into the sum. But if we put this back in, we don't need these brackets, then we're left with the correct answer. Yeah, 27 is the right answer. I showed that, right? 2, 11, 15, 16, 27. Cool. We're not counting these 7s because our code does not count any cells that have the value 7, and we're also not counting the given cell because our code does that too. And yeah, so if you print test 2 mygrid 1 1, you'll see that it's 29, but when we call the exclusive function, it's 27. Thank you, UV. Yeah, and that basically takes care of everything I wanted to mention for the 2D grid building. In terms of going out of bounds and making sure that your grid axes don't go out of bounds. So please, once again, I'm just going to emphasize that the positioning of your conditions within your if statements do matter. Make sure the whole if statement will stop, and Python won't even consider this. Cool. Let's see, what else do we have? Oh yes, there is one more thing. There is one more thing. And yeah, here, let me save this. I will upload this also to, for anyone who's not in my tutorial section, on Avenue, under content, if you go Avenue content, there's a folder called T03, which is my tutorial section, and I put all of my tutorial content in there. So this Jupyter Notebook will also go on there, so you can look at it later on. Let me go over one more thing. So cool. If we had we have a function called find shortest length, and it takes S1, S2. It takes 2 strings, okay? And let's say the point of this function, find the length of the shortest string. And that's what we want to return. So that's actually pretty simple. All we have to do is we can say if S1 is smaller than S2, or sorry, if length of S1 is less than the length of S2, return length of S1, else return length of S2. Cool. If we call this, right, we can print the value, and we can call it with 2 strings. Let's say Basil. We'll say best TA ever. Okay. We find that the answer is 6. which is the length of Basel, which is the length of the shortest string. So it works. Question says, what if they're equal? That's a great question. If they're equal, it won't matter, right? You could return any of them. So if they're equal, it'll fall under this else category, and we'll return length of S2, which is perfectly fine because it doesn't matter which one we return. We can return anyone. Cool? So that works out totally fine. What else do we have? Let's, yeah, so this works, okay? Here is a much simpler way of doing it. Right? You can use the min function. Min function is very useful. Min just takes the minimum of the arguments that you supply it with, right? So if we did this, print better of the same thing, right? You'll see that we also get 6. Cool. So the reason I'm bringing this up is because min can be very useful in determining which of two strings is shorter. I think you will also find this pretty relevant to the test. So keep this in mind. What else do we have? I'm sure you guys all know how to find if something's even, right? Return sum of all even numbers up to n. Up to and including n. Cool. That's a very simple function. Takes in n, and for I in range n, and say result sum, we can initialize that to 0, and we can just add it. Plus equals, or sorry, we have to check if it's even, obviously. So if I is even, which is something like this, right? If I mod 2 is 0, if the remainder after dividing I by 2 is 0, which means it's even, then add I to the sum. Cool. Here's the thing, though. And including. What's going to happen here? This is going to go up to n, but range is exclusive, right? If you don't supply range here is exclusive, basically. So it goes up to n. By default, having just one argument here is the same as saying 0. There's basically an implied 0 here if you leave the argument empty. So we actually have to go to n plus 1, because since range is exclusive, if we're exclusive to n plus 1, then the range will include n, which is what we want. Cool. So now we can return result sum. And let's make a function call and say func. Let's print the result of func at 10, which I think that's right, because you have 10 plus 8 is 18, plus 6 is 24, plus 4 plus 2, which is another 6, it's 30, plus 0, it still is 30. Cool. All right. Yeah, we've covered a lot here. This is really all I wanted to go over. I'll tell you guys once again, the test really is not hard. I know that might sound kind of dumb coming from the TA, but really, it's not too bad. And especially if you understand these concepts, there's a good chance that you understood them before you even came to this review session. But the objective was to A, if you didn't understand them, have you understand them, And B, if you understand them, then really cement the concepts in your brains so that you'll find it very easy and natural to do in the test, and you won't have to spend hours trying to debug and search online for weird, wacky solutions, right? Yeah, that covers everything, guys. I wish you the best of luck on the test tomorrow, and I'll be there on Piazza if anyone has any questions. For the purpose of the test, asking a question on Piazza is, according to Professor Moore, basically the equivalent of raising your hand during a test for help. So you should expect that Piazza will basically have that same functionality. So you can't really ask for the detailed breakdowns that I would usually provide for assignments. But to be honest, I don't think you'll need them because you guys are probably going to kill it. It's not too bad at all. I'll see you guys then, or at the next tutorial if you're in my tutorial section. And best of luck, guys. Cheers.